Video problem 82, the pH scale. Determine the pH of the following strong acids. So the big deal about the strong acid is that when it dissociates, it does so completely. So it ends up looking like that. So that means if this is 1.25 times 10 to the negative third molar, that this is also 1.25 times 10 to the negative third molar because it's a one-way arrow. Right? So how do we calculate pH? pH is equal to the negative log of the concentration of the hydrogen ion, or hydronium, depending upon which one you show. So for this one, it's just pH is equal to negative log of 1.25 times 10 to the negative second. So plug that into your fancy-dancy calculator. Negative log 1.25 times 10 to the negative second. And I get a value of 1. So pH is equal to, now I should have 3 sig figs. So 1.903, and like I said in the notes, that 1, it does not count for significant figures. Anything in front of the decimal after you do a log does not count for sig figs. Okay? Now, 3.5 times 10 to the negative third moles of hydroiodic acid in 250 milliliters of total solution. So hydroiodic acid is another strong acid, so it's going to break up completely like this. So whatever the molarity of that hydrogen iodide is, or that hydroiodic is the concentration of the hydrogen ion. So for this, it's still just negative log concentration of the hydrogen ion. But notice I'm given moles in milliliters, so I have to figure out what that concentration is. So I'm going to go ahead and do that here. So I'm going to take 3.5 times 10 to the negative third moles divided by 0.250 liters, and that'll give me my pH. So I get a value of 1.85, 2 sig figs, 1.85. Okay. 35 grams of HBr dissolved in 1,350 milliliters of total solution. Again, nothing different here. I'm still just going to do, I'll do it over here. I'm still just going to do negative log of the hydrogen ion. I just need to calculate what it is. It's a strong acid, so it breaks up completely. So that's 35 grams of HBr. Let's get the molar mass of HBr here. It's a 1.008 plus the bromine, 79.90. Always show all of your work. I know I've been lately sort of slacking with showing the calculating molar mass, but show that work. All right. So 35 divided by that value gives me a moles of 0.433. That's rounded, divided by 1.35 liters. So I get a value of, for my molarity, 0.3204. Keep as many digits as you can because it's not the final answer. And that's the molarity of the HBr. That's also the molarity of the hydrogen ion, though, because just like the others, HBr breaks up completely. Okay? So I can use stoichiometry. If this is 0.3204, this is 0.3204. So just going to plug that in. And I get a pH of 2 sig figs. Oops. 0.49. No units for pH.